All right, so what has this got to do with our objective here, that is on comparing linear and exponential models? So if you look at the models, the graphs here, do you really think that these models are straight lines, or are they some kind of a curve? Okay, not straight. All right, so since we cannot really decide based on the graph, because the graph some kind of like too small for big numbers, and then so therefore we have to find another way of determining whether these models are actually representing linear or exponential models. All right, so let's take a look at an example here. Okay, I have an example wherein I got this from an old part question, and it says that the table below shows the number of loads of laundry per week generated by a family as a function of the number of people in the family. What does it mean, a function of the number of people in the family? That means this data here is generated by the number of people. So which means the number of loads, which is the other variable, it depends on the number of people in the family. Okay, so we see that if there's only one person in the family, so it's a single family, the number of loads of laundry per week is about 1.5 loads. Okay, so we say that if we use f as to describe the function from the number of people to the number of loads, then we say that f of 1 here is equal to 1.5. So what does f of 1 mean? It says that if there's only one person in the family, the number of loads per week for the laundry is only about 1.5. All right. For the second ordered pair, so how many people are there? 2. So because there are 2, we can say that we have f of 2. And how many laundry loads? That's about 3. So f of 2 is equal to 3. It means that if there are 2 people in the family, then there will be about 3 loads of laundry per week. All right. So one of the data here is f of 4. And that's equal to 6. So where did I get this data? It's from this part here, which means that if there are 4 people in the family, then there will be about 6 loads of laundry per week. Okay, so that's what we mean by that the laundry amount of loads of laundry is dependent on the number of people in the family. Okay, so that's what we mean by a function of the number of people in the family. All right, actually the first question in this item is what type of function is this? All right, so when you say what type, that means is it a linear function, is it an exponential function, or other types of function? Why is it important again to know the type? Because in part B, you'll be asked a question. Okay, there's a question that's related to, or a problem related to this data, and we have to use or create a model, an equation out of this data so that we can solve that particular question. And the equation that we're going to use will depend on what kind of function is this data being shown on the table really is. All right, so let's try to find out. Okay, there are many ways. Number 1, we are going to graph. All right, one way is by graphing the data points. All right, so simply constructing our graph, we have here the number of people, which is along the x-axis because that is our independent variable, and along the y-axis that is going to be the number of loads because that is our dependent variable. And according to our table, if there's only one person in the family, then we only have about 1.5 loads, so the point is here. One family, 1.5 loads. That's the point. There are 2 people, it's 3 points, 3 loads, 3 people, 4.5 loads, 4 people, that's 6 loads, 5 people, that is 7.5 loads, 6 people, that's about 9 loads. All right. So looking at the graph, we can clearly see that the points are on a straight line, right? They fall on a straight line. See, they even are on the edge of these index cards, and we know that the edge of an index card is a straight edge. So the points on the graph here are on the same line. Okay, so because we tried our best to plot or create our graph as accurately as we can, so we were able to plot the points accurately, and we say that the points are on a straight line. So that's why we say that this could be a linear function, okay? Because the points are on a straight line. Now suppose you do not have an index card, nor do you have time to plot the graph, okay? Because we might be in a hurry to finish the test. Alright, so there's another way of doing this. Okay, let's take a look at the change in the number of people. So looking at our independent variable, we see that there is an increase of 1 person each time, right? So that's one increase of 1 person each time. And what happens to our number of loads? So we started with 1 person, and that's 1.5. Now we increase it by, we added 1 more person, and now it has increased to 3 loads. So which there is an increase of 1.5 load. We increase another person, and we see that there is an increase of 1.5. Increase another person, there's also another increase of 1.5. So we see that there is a uniform rate of increase. So there is a uniform rate of increase. Okay, so when you say rate of increase, that is the change, okay, in the change in our number of loads, okay, change in the number of loads, delta, okay, that's this triangle means delta, which is the mathematical symbol for change, and then we divide that by the change in the number of, or increase in the number of people. All right, so this is the rate, right? The rate in the change or increase in load over the change in or increase in the number of people, and it's uniform all throughout. And if you also, and you can also see that in the graph, right? So where if you increase 1 person, there is an increase of 1.5. So that's okay. Then we increase 1 person, we increase the load by 1.5. We increase 1 person in the family, there is an increase of 1.5 in the load. There is an increase of 1 person, and so on and so forth. Okay, so let's just draw the line here so you can see the triangle. Okay, and there you go. All right, so this is your delta x, and this is your delta y, wherein you know that it is, the rate here is, so rate is the change in y over the change in x. All right, the change in the number of loads over the increase in the number of people. All right, So what else do we know about? So we know that linear functions have a uniform increase rate of change for between any 2 points. The reason why the points on a linear function are in a straight line, because anywhere on the line the points always have, between any 2 points there is a uniform ratio between the vertical distance, which is the rise, which is the change in y, over the run, which is the change in x, with or the change in the number of people. There you go. So basically, so what we know so far, if you summarize, that for a linear function, of course, the graph is a straight line, right? And then if in case you cannot graph, from the table, you can see that there is a uniform rate of change. So rate of change could be an increase in values or a decrease in values. All right. And this rate of change is the change in y, which is the increase in your dependent variable, over the change in x, which is the change or increase or decrease in your independent variable. So the numerator is the change in the dependent variable values, then over the change in your independent variable values. There you go. All right. And so because we have a linear functions, then of course you will be able to use what we call here, and another thing, you will also see that there is a constant number that you add repeatedly, right? In this case, we add 1.5 each time because we also added 1. You have a uniform change in the number of people. So we are adding a constant number. All right. And so because we have a linear function, then we are going to use the graph. Remember the linear function, the linear equation, which is the slope-intercept form, which is y equals mx plus b. But because we are using functions, we are now using the equation to describe the function. Let's change our notation. Instead of y, we will use f of x, because actually y now is a function of x. In this case, our x is the number of people, and then the number of loads is our y, and the number of loads is a function of the number of people, so y is a function of x. So in this case, our y is actually now called f of x, and that's equal to mx plus b. So b here is the y-intercept. That's b is the constant, and it is the y-intercept, and this is the value of f of x when x is equal to 0. So in the other case, it's the b is equal to f of 0. Then m times x, that's multiplication. This coefficient coefficient of x, that is we denoted as m, that is the rate, okay, at which the value of y changes. So take note, m here, this is our rate, okay, so that is the rate at which the value of the dependent variable changes as the value of the independent variable changes, okay. So in this case here, as our value of the independent variable increases by 1, the value of the y variable increases by 1.5. Okay, so therefore, okay, so now we know based on what, okay, so our justification here. So what type of function is this? It's a linear function. Okay, so what is our justification? Number one, because we're not able, okay, because we cannot show our graph here, then our justification will be based on the table. Justification is there is a uniform. Uniform can also, word uniform can also be replaced by the word constant, okay? Sometimes we say constant. Uniform rate of increase in, okay, increase, that is for every, what's the increase? For every, okay, an increase for every one person added, person added to the family there is an increase of 1.5 loads in laundry. All right. So having a uniform or constant rate of increase, that is already a justification that we have a linear function, because it's only the linear function that has a constant rate. All the other functions do not have a constant rate over the values of the dependent variable. All right, so therefore, now that we have a linear function, therefore, we can have our equation. So it says here that a family, consider a family that generates 18 loads of laundry a week. Based on the data table, what is the total number of people in the family? All right, so how do you do that? Well, if you do not know how to use or come up with the equation, then you can keep on adding values to your table. So it keep on adding one person here and then until you get to a load of 18, right? But that's quite a long way. Okay, so what are we going to do? We're going to use our equation. All right, so we have y equals mx plus b. Okay, so, well, you might say, why am I using y? Well, you can use y. Well, basically, that's our f of x. Yep. All right, so equation y or f of x equals, our rate here is 1.5, right? Because for every delta y, okay, so rate m is equal to delta y over delta x. Delta y is 1.5 loads, and then we divide by 1 person, so which means that's an increase, right? Increase of 1 person. Basically, it's just 1.5, so that's 1.5 loads times x plus b. Of course, if there's what's your initial? So if there's nobody, so remember when x is equal to 0. All right, if there's nobody using anything, then obviously the load will be 0. So that's going to be just simply 1.5x. Okay, so f of x is equal to 1.5x. X is the number of people in the family. X, number of people in the family. Okay, so we're asked for what? How many loads? So f of x here is the number of loads. Take note, y is the number of loads, and it says 18. So 18 is equal to 1.5x. So here we're going to solve for x, the number of people in the family that will require 18 loads of laundry in a week. And because x is multiplied to 1.5, we divide both sides of the equation by 1.5 so that we can compute for x. So 18 divided by 1.5, that should give us 12 people. Okay, so x equals 12 people in the family. All right, there you go. To summarize, for a linear function, the graph is a straight line. And if you're given the table, you will see a uniform rate of change. The change could be an increase or a decrease. And to compute for the rate, it's delta y over delta x. It's the change in the values of your dependent variable divided by the corresponding change or in your independent variables. And of course, you will see also that there is a constant number that's being added, and because of that, our equation will be y equals mx plus b, or because y is a function of x, then we can also denote y as f of x. So f of x is equal to mx plus b, where y is the y-intercept. When we say y-intercept, that is the value of the function, the value of y when x is equal to 0. Or in function notation, we say f of 0 is equal to b. And of course, the number that's multiplied to x, we call the coefficient of x, is the rate of change. That is, again, delta y over delta x. Delta y is the change in the dependent variable over the corresponding change of the independent variable values.